Hello everyone and welcome back to my Tech vs. Magic series. Today we're going to continue working on this. Hopefully finish it, probably finish it. Maybe even have enough time to work on something else, but we'll see. Going to do mostly the programming, but first let's go over a few mistakes that I had made during the previous episode. First off, this was facing the wrong way, fix that. Over here, this whole area here was not connected to anything, so I added these 3 frames right here to hold all this stuff, the rest of it. Then I forgot there's supposed to be an RS latch connected to this, so I had to move this from here over to here, and the chest from here to here. This gray wire is there, and I added the brown wire. And this is an RS latch, you just have to shift click on it a few times. So normal RS latch, swaps again, and that's how it should be, I think, with the, with the gray light off. Then we have the computer set up like I said. IO expander, disk drive, monitor, and CPU. Then the backplane and RAM module. And I tested the basic movement of everything. So the platform moves properly, and the piston head will move up and down properly. Not the piston head, but the digging head. So let's see. First we're going to, I've already put in a disk here, and I've loaded up the words from the utilities disk that we did in the Crucible automation episode. Absolute value, clean disk, wait for signal, log 2, pulse, and the various colors of wire from white to black. And then the normal extended fourth dictionary. And I've made a utilities boot disk so that I can just boot with all that from now on. And now we have a blank disk in here that has been cleaned with the clean disk command. So we're ready to go. The first thing we want to do is to do a dig command, a dig word. So let's see what we need to do that. So first off, we want to, let me find the word I am looking for. I think, yeah, okay. So we'll do one list. This is the first block in the disk. And this is where we're going to start with. So line 0. We're going to give ourselves a note telling us what we want this to be, what the word is going to be. So it is not going to have any arguments. It's just going to dig until diamonds. That is going to be what this command is going to be, and for simplicity's sake, we're just going to call this dig. Then we'll start defining it, and put this notation, ... nothing. No arguments needed. Then on the first line of the word, we will have, actually I did that wrong, didn't I? It's supposed to be, dig. This is why we do it in the disk, so that we can fix mistakes like that. Now then, let's see what we need to do to dig. First off, we're going to have an indefinite loop. So we're going to start that. Actually, let's tell ourselves we're starting our loop. So this will print it out to the screen. Start. I like to use not all caps when I'm doing comments or printing out stuff, so it's easier to read for myself. Starting to dig down. And then an in quotation marks for that statement. And I'm going to, let's actually look at this, and then I will type it all out. So to dig down, let me make it daylight. Dig down, how we're going to do this. The first thing that needs to happen is that, let's see, if we've just dug down, or we're just starting, we need to break the top little, this block right here, so that it can move. Then the next thing that needs to happen is this needs to place a block. So we go magenta, then yellow. Then the frame motor needs to go down. So that's white, magenta, yellow, white. Then we need to replace actually that's not right. That should have already been there. So it's break just magenta, then it's magenta white, then yellow. That's right. Magenta, white, yellow, because that block's going to already be there. So magenta to get rid of that block, yellow to move it down. No, not yellow. White to move it down. Yellow to place the block that's below this one. So yellow replaces this block. Then we pulse the light blue to replace that top one so that the signal will connect all the way down to the block breakers. And then we pulse the block breakers with the, what color are you? With the pink signal. We'll pulse the block breakers. And then we will repeat the cycle. Yes. So it is magenta, white, yellow, pink. No, magenta, white, yellow, light blue, pink. And we need to do that in a loop. And after we get finished doing that, we need to check to see if there's a gray signal before we continue the loop. So I'm going to type that out into code form, and then I'll show you how it looks. I've gotten all that typed in, but first, before I forget, we need to place this world anchor. I have it right here on this boundary of the chunk in the Z direction, which is this way. We want to make sure that it's just inside of the chunk with the arm right here. That way, if we're moving that way, we don't like shear off part of it from it not being loaded. So just put it there. Doesn't really matter in this direction, I don't think. Yeah, there's still plenty of room there for that to move. Okay, so let's see what we've typed in. I had to split dig up into 2 words so that it will fit in blocks. So dig is now just dig down and then retract. That's the word dig, but the word dig down is dig down until we hit redstone or diamonds, and it leaves in on the stack, which is how far down we've dug. So dig down, start to dig down, that just prints that out. Then this is the colors we said we need. So we put 0 on the stack to act as a counter for how far we dig down, so we know how far to pull the arm back up. And that's the number that's going to be left on the stack. And then we begin an indefinite loop that goes from begin until. Then we just go through these colors and pulse magenta, pulse white. Then we wait 18 ticks, so this is a total of 1 second. And white is the frame motor, that's why we're waiting for that 1 second. Giving it time for it to move. Then we pulse the yellow, then the light blue. Then the pink, that is the block breakers. So we pulse that, and then we have this little bit complicated wait command, which is all this from here to here is all a wait command. So let's see, what we're doing is duplicating the first number, or the number that's on the stack, which is the counter. So it's how far down we've dug, and multiplying that by 20. So we're 20 for every block that we've gone down. Then we're adding 500 to it and waiting that many ticks. So this 500 is, what is that? 5 by 20, 25 seconds, I think. Does that sound right? Yeah, 25 seconds. Yeah. So 25 seconds, I counted, it moves, the blocks move through the tubes about 1 second, or 1 block a second. So items move through tubes about 1 block at a second at that speed, which is not something that I really considered when I was building this, because that ends up being quite a long delay once you get lower. If we ever redesign this, we'll have to take that into account and improve that limitation. But we're waiting for 25 seconds. That's how long it takes to get through the digging head and through here to reach the item detector. The 20 seconds times the how far down we've dug, that's the extra delay for how far down it takes to get through that shaft as we go lower and lower. So it waits that long after it's pulsed the block breakers for the items to get through. If you don't wait that long, the block breakers will get back stuffed and just won't break anything and it'll mess everything up. Then we have, where are we? Okay. Then we add one to the counter. That's what this does. So this duplicate command, we copied the counter, multiplied it by 20, multiplied the copy by 20, I should say, then added 500 to that result. And then waited that long, then we add one to the counter, make a copy of it, and print out that copy here. So we have dug down, print out the number, that many blocks, carriage return. Then we read from the IO expander. So we're checking if there's any signal coming from the gray line. Check for gray signal. Then this line here is something that I've just added, and this is in case we don't hit any diamonds or redstone in this area. Basically, if we get to bedrock, then it will tell us to retract. But first, let's ignore that line 12 and say the until is a check to see if there is a true or false statement, and the way it determines it true or false is any non-zero number it counts as true. So if this doesn't have a signal, it returns 0, and this is false, so it continues looping. If it does have a signal, it returns the number that is associated with the gray wire, and that counts as true, and the loop will stop there. But here, we're going back up. So we're swapping the IOX result with the counter so that the counter is now on top, making a copy of the counter and seeing if the counter is greater than 116. That's what these two things do. If it is greater than 116, we will swap that, take the IOX result, put that back on top of the stack with the swap command, drop that, then we make another copy of the counter, and that copy is what's going to be checked with the until. That's only if we're greater than 116. If we're not greater than 116, we'll just swap it back so that the IOX result is still back on top and end the if statement with the then, and it will run like we said before. Then this is the end of the word dig down, semicolon. Retract, it just retracts the digging head. This is one that's very simple. The first thing we do is disconnect from the platform by pulsing the light blue. Then, see, light blue is this one. Actually, that connects it to the platform. So the other thing should probably be magenta, actually. But it doesn't really matter anyway, because this will disconnect it from the platform. Or no, the lime will. But anyway, then we do a loop here. So just ignore this. This is not necessary. The lime, orange, and then at the end of the loop we need to do yellow, light blue. But this takes the counter that we have up here from the end result that this left on the stack and makes a loop that many times. So from the counter to 0, it will pulse lime, a 2-tick pulse, which is this block breaker here. So it's going to break that block, and then it's going to pulse orange for 2 seconds, or 2 ticks, which is that upward facing frame motor, and that will pull the head up 1, and then it's going to wait the 18 ticks to make that an even second. 2 plus 18, 20 ticks equals a second, and that will give it a delay to wait for the frame to actually move everything, and then it will continue doing that until it has moved it up as far as we went down. And that is the end of the loop here, the loop. Then it will tell us we're finished retracting the head. We're going to reattach it to the platform. To do that, we're going to pulse both the yellow and the light blue. So we will do both of the deployers will pulse yellow and light blue to make sure it's connected back to the platform. Then the brown will pulse, and that's going to reset this RS latch so that the gray signal is now off again. And then it's to finish the digging cycle. And that's the end of the retract word. Then we just have the dig word, as I said before. Now then we need to make a set of commands to move the frames. I'm going to do it kind of like I did last season. Just have it move east, move west, move north, and move south. So to move east, that is over here. And let's see, this pushes it this way, so east is, no, this is west. West is purple, east is blue. So we'll go to 3 list. There's nothing here. Just making sure that we're ready to edit 3. That's 0. So 0 pp. We're going to define a new word. This is going to be move west. And what color did we say that was? Purple. So it's going to be purple pulse to, whoops, it's purple 2 pulse. So pulse purple for 2 ticks, wait 18 ticks for the thing to actually move. Then we're going to do that again. Actually, let's just make a loop to do this, so we can fit it all on one line if we do it that way. So I'll loop it twice, then we'll do purple 2 pulse 18 ticks loop semicolon, and that's the whole word. So we just need to do that with every color, or the 4 movement colors, and I'm going to do that and be right back. Okay, got that all typed out. So we have move west, move east, move north, and move south. They're all the same, just the wire colors are different. And the next thing we're going to do is make the actual Quarry command, which is going to have two arguments, z chunks and x chunks. It's going to quarry a z chunks by x chunks area out. And this is going to be positive for the z direction, and this is going to be positive for the x direction. So to start with, we need to define a word which we're going to call Quarry. And this is going to be that up there. Then we need to have a check to see. Well, actually, first off, we're going to do a dig command. Yes. So let me type all this out and I'll be right back. Okay, so I've done that. But first, let's see. Before I forget, I added a couple of stacks of redstone tube frames. Frubes, I think they're called, to here, so that this will have something with which to place some blocks to place as this goes deeper and deeper and deeper. I've also increased the delay of these, so this is at 10 now instead of 2 because it was causing some problems with it just not working for some reason. I don't know why, but increasing the delay seemed to help. I've also changed it down here, and I increased the delay for the move commands to 30 ticks afterwards. That is because when this moves several in a row, it uses up all its power, and it takes a little bit extra of time for the power to come from here and refill that once it moves back. Then I think that's everything. So let's look at the Quarry command. I went ahead and moved that to the next block because it wouldn't fit in that one. So Quarry is still z chunks by x chunks. The first thing we do is we want to see if x chunks is negative or positive. If it's negative, when you do a do loop, you have something like 10, 0, do something, loop. But if it's negative, it needs to be 0, negative 10. Do something, loop. So we need to have the negative number second. And that's all that this line is doing. Well, these two lines are doing. This one is making a copy of x chunks. It's checking to see if that copy is less than 0. If it is, it will push a 0 on the stack so that the stack looks like that. Oops. Oh crap. Let's try this again. Typos. It does not like typos. So the stack looks like that. And then it runs the swap command. And that makes the stack look like the way we want it. If it is positive, the else, it just pushes a 0 onto the stack so that it would be in this format. Now then, we start an outer loop, which goes from here to here. The alignment got kind of messed up there. I was too lazy to fix it. And part of that's just so everything would fit. It's a little bit denser than my normal code, but yeah, from here to there. Then the outer loop, and it prints the counter with I and then dot. I is the counter. Then the next line here is this part from here to here is the exact same as this, except for This is for the Z chunks. And we're also making an extra copy of the Z chunks so that when this outer loop runs again, there's another copy up here for us to work with. Then for the inner loop, we print out the inner loop counter. And 4 times 4 to 0, we will do a loop here to here. We will dig down. Then when we're finished digging, we're going to move west 4 times. And that way's west. So this is going to dig all the way down until it hits redstone, retract the head. Then once that is finished, we're going to move west 4 times, which is the width of that. And then it will dig down again, and it'll do that 4 times until it's dug out this whole chunk. And after it's finished digging out the chunk, it'll tell us it's finished digging out the chunk. Then it's going to move back to the beginning of the chunk by moving 16 times to the east. Then it's going to move to the next chunk in the loop. So it's going to move this way or this way to the next chunk and start quarrying out that chunk. So to know which way we need to go, whether we go this way or this way, we need to know if it's positive or negative. So if we take the counter, and if that's negative, we will go north 16 times, 16, 0, do loop. If it's positive, we will go south 16 times, 16, 0, do loop. And that's the end of this if statement with that then. So positive, negative. Then, end of the inner loop here with this loop. Then we're going to take the extra copy we made of the Z chunks counter and negate it. That way, well, I'll come back to that. We're going to negate it. Then we're going to do the exact same check we did right here, but we're going to do that with the X chunks. The outer loop counter, I should say, which is also the X chunks. So we're going to see if that's negative. If it's negative, we move east. And if it's positive, we move west 16 times. Then that's the end of the loop, and it'll go back to the beginning. After the loop finishes, we drop the extra copy of Z chunks that we have, and then we tell us we're finished quarrying, and we end the word. So the negate command is after this. So say we have a 2x2 quarry. It's going to dig this chunk out, move back here, then move up to that chunk, quarry that chunk out, wait. Then it's going to go to the outer loop and move over this way, which will mean we'll be at that chunk there. And then since it's negated, it's going to go in the opposite Z direction. So quarry out that chunk and then go back to that chunk. And that's how it'll be ended. It'll be over here. So it just goes this way, then this way, this way, this way. When it's doing the inner loop, it's just switching which direction we're going to the inner loop so that we don't have to go all the way back. It's a little bit more efficient. The pathing isn't entirely efficient, but it's kind of simple. And simple is better in this case, I think, as the inefficiency isn't too bad. So I've already loaded up the words. Quarry, move, dig, retract, dig down. And I did that just by typing one load, given that I have these blocks to load the next block already embedded. So when I type one load, it will load all 4 blocks. Now then, let's take that, put it in a blank floppy, and we're just going to save this. It's Quarry. And that's going to save all the compiled words and all the 4th words that are already in here, and we can boot from that disk. Hence the name. And we don't have to do the load command, which takes several minutes to load the disk up from the word disk. So that just speeds things up a little bit, and it doesn't take very long to save either. Now then, what we're going to do is do a 2x2 quarry and just let that get running. And I forgot to put some carriage returns here, but I'm too lazy to fix that, and it doesn't really matter. So outer loop counter, inner loop counter, starting to dig, and that should be going on. See it move down here in a second. Again, there's the 25-second delay plus one more, or plus 1 second for every block we go down delay between when this digs to get this item's time to move up through there. So that's going to be digging. Yeah, I'm going to let this go a little bit further and then I'll be right back. Okay, we are back. I added a extra frame to this top, an extra redstone tube frame to this top deployer here because it takes longer than the delay between these for the tube to move through. So there's going to be an extra one in that top one just to counteract that. Then as you can see, we are digging down quite easily. And if we watch this stuff come up, you should see how accurate the delay is. There's the stuff coming through. And it just finished. So we have 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6, 7, 8, 9. So it's about 9-second leeway in that part. But that's fine. I just wanted to give it a little bit of extra time to make it to the item detector, which is another 1, 2, 3, 4, 5, 6 seconds. So we only have actually 3 seconds left extra. So not a bad deal. And yeah, I think we're going to end this here. Next episode, we'll be working on something else. Not the other mining machine, I don't think. I think we're going to try to do something with the sorting room, at least start on working on that, so that we have something to do with all the output from here. Because this is going to be doing quite a lot, and we'll come back to see what kind of hole this is dug after this is ran for a while. But it seems to be going fairly quickly at the beginning at least. Anyway, like if you like, subscribe if you're not. Thanks for watching, and I will see you next time.